A 5.58 meter long steel beam, so I guess that would be the length of the beam, is 5.58 meters, is accidentally dropped by a construction crane from a height of 7.79 meters. So my height equals 7.79 meters. The horizontal component of the Earth's magnetic field over the region is 28 microtesla. So my B field is 28 times 10 to the minus 6th Tesla. Micro means times 10 to the minus 6th. The acceleration of gravity is 9.8 meters per second squared. What is the induced EMF in the beam just before impact with the Earth, assuming its long dimension remains in a horizontal plane oriented perpendicular to the horizontal component of the Earth's magnetic field? This is perpendicular, so that means that my theta is going to be 90 degrees. So this beam starts up here, it falls down. After it falls down, it's going to be moving at some velocity. That velocity is going to be necessary. So how fast is something after it has fallen 7.79 meters with a gravitational acceleration of 9.8 meters per second squared? You might remember that your final velocity is going to be your initial velocity. V squared is V0 squared plus 2ax or 2gy, depending upon how you want to write it. So my final velocity squared is what I'm looking for. My initial velocity is 0, so it goes away. So my final velocity squared is going to be twice my negative 9.8 times my displacement of 7.79 meters negative. So that is going to give me a final velocity of something. Now that you know your velocity, now you want your strength of the induced EMF. So when you see EMF, that's the same thing as this funky symbol, this curly QE, which is actually the voltage. And so to get the induced EMF, it has to do with the strength of the magnetic field times the length of the rod times the velocity that it is moving. And then you need to be perpendicular, so that's going to also be sine theta. So BLV sine theta will give you your induced EMF in that rod. So you got your strength of magnetic field, you've calculated your V already, the length of the rod is given, so that will give you your EMF. But this says answer in units of millivolts, so whatever you get for your answer in this is going to be in volts. So to get it to millivolts, you're going to have to do times 1,000 to get it there.